Okay, so I'm now at Ant Spirit Company with Mr. Afizan, the technician here. So today we will talk about this vacuum forming machine. Okay, vacuum forming is basically a process of where you have an object and then you let the plastic draw upon that object. For example, let's say you have this type of object and then you want to mold this object. What you do is that you use this plastic, okay, and then you put on top of this object, you heat this plastic first, and then when it's heat enough, you draw the plastic near the object and then you let the vacuum suck the air. What will happen is that you get this this what I call this mold. So you can see clearly. So you have the hollow here, hollow side there, and this is the protrusion part here. So we use here this Formech, the vacuum former by Formech. So the model here is 508DT. So this is desktop size vacuum former, even though it looks tall, but beneath here is just what we call just a trolley. It's nothing more. So the vacuum is internal, so you don't need to use any external vacuum. And on top here is a heater where you use it to heat the plastic. So the vacuum at the bottom, the heater at the top, and your sample in the middle. Okay, let's take a closer look at this machine. So here you can see we put our sample in the chamber there. So this is the stand where you put your sample. And this machine, particularly this 508DT model, have the opening of about 482 times 432 millimeter, or in inch, 19 inch times 17 inch. So that is the what we call the maximum forming area. However, when you want to use the sheet, for example here, the plastic itself need to be bigger than the what we call the area of the forming, which is about 508 times 457 millimeter, or 20 times 18 inch lah. So the bottom line, the plastic must be bigger than the what we call the area of the forming.
Here is a button for you to turn on the heater. So you have to turn on the heater while waiting this machine. This machine need to be preheated before they use. And then once heater is fully heated, then we have to press this button and then this hand button, and then we can start. So let's see, now we have to wait maybe for a few minutes, heater to be preheat, and then we start to mold.
You can also use a smaller windows rather than this big one. So we do have this reducing windows, we call it reducing windows. Okay, so the advantage of using this, if let's say we put on top of this, okay, you can save a lot more plastic lah. For example, this plastic is quite expensive for this size lah. You can also see is quite thick. Okay, sometimes the cost about like 30 ringgit per piece. So it's quite expensive. So sometimes people want to use small plastic only. Normally, they use that small plastic when they have object that is very small. For example, like my watch here. So if you want to vacuum form my watch, then you don't need this entire area of plastic. You just use something small, so you can save more plastic and reduce the waste lah. So today we would like to what we call to vacuum form all this stuff. We will talk about this later on, but first we want to talk about this plastic. Okay, so today we want to use this PVC plastic, a transparent one. Normally when you want to do vacuum forming, 0.5 mm thickness is a good plastic lah. So this is 0.5. But if you have thicker plastic, then you can draw better lah. For example, if you have something that is very high, when you do vacuum forming, the plastic become thinner and thinner. So if you got like thicker plastic like 0.7 or 1 mm, then it's better lah. But if you have something like very what we call the height is very minimal like this, then using the 0.5 is okay. So we have here, this is for the small one, for our use with this reducing windows. And this when we want to use the maximum area of the machine lah. So here we have this what we call the size is about 4576110, which is fit for our vacuum former maximum windows for our machine. and this is 0.7 mm of the same size lah. So back to our sample. So we categorize our test sample today to 1, 2, 3, 4, 5 area. So the first part is the everyday object. You can see here we have that we call the scissors and also the toys. And we also want to test what happens if we try to vacuum form something that is double the height. Does it make any difference? And also here we have something quite difficult to form because you have what we call undercut bottom here. Okay, so we want to see whether we can take it out from the mold or not. So here is just like alphabet. We want to see whether during the vacuum forming the plastic will go through this hole or not, or does it able to form a shape to this narrow slit there. And also we have this everyday object. This might be easy to form because the shape itself is very simple. We also have here a plasticine, a modeling clay. So we assume that it doesn't work, but then we just want to show to you that you need something rigid in order to do vacuum forming lah, because you use like very hot plastic draw to the object, and if the object is not rigid enough, it will sort of like melt. So this is just a test. This is a modeling clay. This is just typical polystyrene. Okay, so it's like this. They have this consistency. We want to see whether it will melt or not during the process. This is like a foamy substance. Okay, maybe it doesn't work, but it's okay. You just want to test. And this is quite hard polystyrene lah. Normally you get this when you sort of like buy something big. So come in the crates of container. Normally they use this to dampen the vibration. Okay, so this is quite hard. Okay, compared to this polystyrene, typical polystyrene is more squishy than this. And also we have this what we call the container here. The purpose we want to test this is just we want to test the undercut. Normally when you want to vacuum form this stuff, you do like this, meaning that you put the plastic from the top. The plastic from the top goes down, so it's easy to to remove this object afterward. But we want to try what happens if we try to vacuum form this in this way. What happened, because if you look here, there are some indentation there. So if let's say the mold is the plastic envelope this this container, it will sort of like the plastic will go underneath here, and then it will make it difficult to remove this object afterward. Okay, so this is for our first test lah. So we call it the everyday object test. Okay, the second, this is our 3D printed object. So here you can see we put some hole there to allow the vacuum to be sucked in this area, so that it can get a sort of like defined structure there. Okay, if there is no hole, then the plastic will not be able to draw to this base lah. Okay, it's not really base, but at least the base for the hole here. Okay, and we want to test what happens if we increase the height of this holy square double or quadruple. I believe this will not work well, because the plastic become thinner and thinner enough until to the point that it will break. Okay, so it's okay. We will check later what will happen to this. So this is 3D printed object using PLA. Okay, and we know PLA have some problem in terms of what we call its temperature. Normally PLA will melt at lower temperature compared to ABS or other 3D printed filament. So what we did here is that we want to test what happens if we coat the PLA with epoxy. Okay, so this is what we call this epoxy. You can see the shiny. Okay, so this is non-coated PLA. This is coated PLA. The idea for this test is just want to see what happens if we coat PLA with the epoxy. Does the heat from the plastic deform this coated PLA or not? Okay, so this is the next next part. This is a complex structure. So the idea here is that we want to see by how far our vacuum forming can assume the shape of this object. And the last one is we use a cast plaster of Paris. Okay, so this the reason why we do this is because previously when we use this PLA, we found that after vacuum forming, the top of the PLA become not melted but deformed. So now we try to cast using plaster of Paris. We know plaster of Paris is ceramic and people use it for making vase and putting it in high temperature. So this one will not be deformed through heat lah. Okay, so now we want to spray our container here because our plastic is transparent. Then if we use this transparent plastic for as an object, is difficult for you to see it clearly lah. So that's the reason why we spray. Okay. Okay, so we spray in this whitish color, so at least you can see the contrast later on when we do this vacuum forming. Once we put all the sample on the table, so it's time for us to pull down the lever back. So this table will go down like that, and then we will put our plastic on top of here lah, on top of heater. Okay, so we take the plastic there. So this we will use 0.7. 0.7. 0.7. This 0.7. We use 0.7 because we have like some height here. We have this some height there. So we afraid that if we use a very thin thin plastic, the plastic will get burst before it draw to the bottom. Although I don't think so, but yeah, better safe than never. Make sure your plastic is bigger than the opening window lah. That's important because they are vacuum sealed there. If your plastic is just the size of the window, then there are no sealing happen. So now this is our guard.
Now we have to press the on button. So the hand, and then we start pulling out this heater.
Okay, so we bring in the heater there. This heater, the way how we heat it, we heat it based on percentage. So now we heat it at 70% percentage of its maximum capability lah. So this is how long we need to wait. So we depend on different plastic will heat at different temperature lah. I mean that we need the plastic become a little bit malleable before you can do the forming. Okay, so if you have thick plastic, the longer it takes. So here, let's say we try how long? 70, 72, 75. Okay. Yeah. So let's see. So you can see now the plastic become wrinkled. Okay. Okay. So just a little bit more. So but that's what happened. So the heater will hit the plastic. So now when you close this thing back, it will reset the timer. So previously we already have 70 seconds. So now add another 20 seconds maybe. Okay. So after 20 seconds, okay. So now you can see the wrinkle happen there. And now it's time for us to bring the table up. And you can see what happened now. Okay, it's okay. And then we start the vacuum. So we can see what will happen. Okay. So this what you see here is basically there are some bocor some hole there. Okay. So it's they are not sealed very well there. Okay. So now we try to reheat again. We want to see whether we can use the best practice is just to use a new one lah, because that's you get a virgin plastic, but sometimes you want to save money. So we just reuse, although the result might not be the best lah. Previously we used how long? 70 plus 20? 90 seconds to hit this thing. Maybe we need to add another 30 seconds or like that, so that so that it will sort of like become more malleable to be formed. Okay. So now we close the machine. Okay, so you can see it's malleable now. Okay, so we bring the the thing up, and then we vacuum. So that is vacuum forming, yeah. So you can see this already melt. Okay, it's okay. So this also melt. This also melt. This also melt. This also melt. This is wood. It's okay. This melt. Oh, my wife will kill me. Anyway, this is okay. This metal. So the big takeaway is that you need something rigid and not really plasticky lah. As you can see here, this it will not melt, but then it will crush. So that's why you don't see anything. So this totally melt. This is what? This is like whatever this thing. So this is polystyrene. Okay, polystyrene. This is what I call the plastic, the toy, the Lego. Okay, it's quite hard. Okay, so we can use the compressor. So this is a compressor. Okay, so you can see you can actually pull up if the design is okay. In this case, you can just pull it up, but there are some design you cannot pull up. For example, this one is already what we call undercut lah. You can see here. How can you take out this stuff, because the plastic is undergo beneath it. So this is what we call undercut lah. So it's very difficult to cut unless it doesn't work lah. So you need to make sure you put your sample, the geometry or the orientation of sample matters. Yeah, so that's how you use the air compressor. But of course, this is not useful lah for our purpose. But at least you know lah, you can use the air compressor to remove this stuck sample there lah. Okay, we successfully taken out some of our toys, although it's not really usable anymore. One more thing is about these scissors. At the beginning, we thought that we can taking this thing out easily, but we are wrong. Because why? Because this blade here is not flat. When it's not flat, the plastic here have some place to creep in. This is what we call undercut lah. So the plastic here you can see here the plastic preventing the blade beneath that from getting out. Okay, so in this case it's hard for us to to take this sample lah, because this plastic itself that we use is rigid plastic, hard plastic. If this is silicone, then it's easy, you can just stretch it apart and so on. So when you have this undercut design, then it's better for you to use what we call the silicone or 2 mole or whatever. But if you use a vacuum forming, which is a 1 mole piece method, then this quite a problem lah. You cannot take it out from the mold itself. When you have undercut problem, normally you will sacrifice the entire thing, that you will sort of like cut this plastic to take out your object, or you can do last try by what we call cungkil. So using this what we call whatever lever you have, and then try and pray that it will come out. So here it coming out. Okay, so as you can see here, this is what I call the undercut here. So you can see the plastic, there are some area beneath the plastic on the top here. So that's what prevent we taken out our scissors easily just now. But because this plastic you can a little bit flex, then you can take it out. So this is what it look like lah, the vacuum forming, what it look like. So you get the what we call the mold for the scissor. So the vacuum forming typically used for packaging, for molding and so on. So this is what the successful vacuum forming looks like lah. And this is what the failure looks like. So normally in research, there are a lot more failure than success. So this is what happens when you use wrong material for vacuum forming. So this is clay. So clay is easily deformed under heat. So you need to what we call to cuci, to wash again, and so on. And here you can see there are the hole there. So this is a hole for the vacuum. For the second test, we will use this our plaster of Paris. This is hard, so hopefully there are no problem with this. So as usual, we put on the table first. So this is our table, and for this we also use our biggest, the maximum area, the plastic. So but this time we use 0.5 only. So here 0.5 mm. So that is the size that can accommodate the entire windows of the vacuum forming area. So we use 0.5 because all this thing is quite low in height. So hopefully there are no problem for this. If you look here, there are some hole here and some hole here, but there are no hole here. You can see there are some defining structure there. So when you have some definitive structures or what we call the side here, it's good to have hole so that the vacuum can go inside this hole, making this structure defined during the vacuum forming lah. But this, there are no hole, so we see what's the difference between this part and this part. The rest is, I think, is self-explanatory lah. It's just a simple shape. Okay, before this we used 0.7 thickness PVC, but now we use 0.5. Previously we take around 120 seconds to do our forming, but this time because it's thinner, then maybe we use 110. How much? 110. 110 seconds lah. So you can see there, and then we take it out. And then we suck the air. Okay, so you can see it's quite nice. Everything is perfect now, so there are no problem. Because why? Because we use hard material there. Okay. Okay, so now we done, and then we push the air in. Okay, we will push the air in. Okay. 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 We push, we suck, and we push, we suck, we push in to what we call to help us to remove the mold, release the mold. Okay. So you can see here the difference. If you use right material, rigid material, then your work will be much easier. So we can conclude for what we call for this vacuum forming, if you use a plaster of Paris cast, then it's very easy lah. You can see. So using the air is basically push the thing out, and you can see this sample have a lot of feature there because I make this using a plasticine and also using hand. That's why they are not flat. But during vacuum forming, you can see everything is captured here. So it's very, what we call, you can see here, it's very detailed lah there. Okay, so depending on what you want, so you can design accordingly. So let's take it out the rest. So as you can see, we can take out most of it because all the sample have what we call some draft there. So it's easy to take out when you have make your design in certain angle like that. So it will just pull off easily. This also can be easily pulled, but the problem is this we have undercut here. If you can see, if you look here, let me see. Okay, so this is undercut here. So here, so you can see there are like what we call, there are some sample. Maybe here this is much more clear lah. Okay, can you see? So there are a plastic stuck there. So the sample at the bottom is much bigger than on the top. So the plastic will assume the shape and making it hard to take it out. So this is what we call undercut lah. Okay, so I'm not sure whether you can see clearly or not, but hopefully you can understand lah. So you can see here there are some undercut, meaning that the bottom is bigger than the top lah. I mean, the bottom is bigger than the top. Normally you want the top here, the top here is bigger than the bottom to prevent the undercut. You use plaster of Paris, sometimes you can see the residue there, the debris of plaster of Paris here lah. Maybe my mixture is not too perfect. Normally when you have like perfect mixture, you don't have like called the chalk coming out, but it's okay. Just you need to to clean it before you use the next. Okay. So yeah, just a plaster of Paris there. So just clean using the duster there. So because we don't want this thing goes inside the vacuum. Okay, for this sample we will use reducing windows. So this is reducing windows. So the area is smaller now. Here we will use 0.7 thick PVC, but I'm not sure whether this tak lepas. Okay, tak lepas. So maybe we book only one only, boleh. We just because if you put like this, it's not enough lah. You pushing it to the limit. So in this case, it's better you try one here like that, because at least the plastic have some area to draw inside lah. Although I'm not sure whether this will be working or not. But yeah, we try. Okay, so there are two parts of reducing windows. So here the bottom part you have this silicone sealing area there, and then the second part you have another windows there. So you put your plastic in the middle here, and it will clamp there like before. We have our sample here in the middle there. This is about like 10 centimeter high, and we will use what we call the 0.7 PVC for this case. Okay. So the concept is same as when we use like maximum windows. It's just this smaller lah. Okay. So you can see this condition of our plastic. So we pull it up and then we vacuum it. Oh, betul. Okay, can you hear the sound? So that is the sound of the what I call the plastic pop. Pop because the what I call the size the height is too high and the amount of plastic is too little. And as you can see, because you use PLA, it's melted. Okay, so that's why you cannot use the PLA. Okay, maybe the ceramic is the best, but if you can coat this PLA with epoxy, maybe working. But in this case, it's not working because the height is too high and the amount here is too small for the plastic to go down. Okay, you can see there is the hole there. You can see the hole. I don't know whether you can see. Oh, so that's the hole. So the plastic doesn't have enough stretch to go down there. Because yeah, and also there are some what you call some cushion here, because of course there are air pocket around here. Okay, wrinkle. Okay, normally when you make thing too high, then they will have this pronounced lah. But if you make something small like this, you can see there are no wrinkle happening there, because the what I call the plastic can easily go down and leave no mark like this. No, what I call, we call it sheen or whatever this thing. So as you can see here, the thing they try to pull, the machine try to pull the what I call the plastic into this part, and you can feel it here. This is very thin compared to here. This thick 0.7, but this is very thin. Okay, so yeah, this height cannot go. But if you have like a big one, the height is high but then it's big, then that's maybe work lah. But because this is too small, the opening is too small, that's the problem. Okay, so now we test another sample. So this square hole also, but this is half the height of the previous one. So this is 50 centimeter, and this is half the height of this. This is 25 centimeter. So we allow some gap here so that the plastic can shrink and goes inside. We're not sure whether it can go down there or maybe it pop like before. But here maybe it can work lah. But this is dubious. Maybe the plastic will pop. We will see. And here we use a 0.5 mm thickness PVC. Okay. For 0.5 we will reduce the what I call the the what I call the timing for heater around like how much? 95 second. Okay. So you can see that how it's wrinkled. Take it out. Okay, let's do the forming. Okay, the pop again. But as you can see, the pop happened on this what we call on this 50 mm height. But this one is okay. This one is okay. So it shows that the height matters lah. If you have a small opening, the height matters. Because remember, the plastic need to be draw down. Even here, it's not really what I call. It's not really the what I call the plastic is not go to the edge there, because as I said, the opening is too small. Then it's hard for the plastic to what I call to change itself and goes into inside there. And also that's the reason why we put the hole there. Without hole, then there are no air to pull this plastic down. And here this is the reason why we give some area so that there are some plastic can goes inside there lah. And here this what we call the what is this? Wrinkle lah. Okay, so normally if you have something high, you vacuum form it that object alone lah. Don't do many, because it will sort of like make some compromise lah. So this is compromise because of air pocket in between of this. Anyway, so we can conclude now that the height matter lah, and also not the height matter. I mean the height and also the opening. If the opening here is big, then if you have this 5 cm height, then still okay. But if you have the opening is too small, then they are very difficult for plastic to go inside. That's why it becomes thinner and thinner and it's pop, like just you see now. So now we test this what I call the low height sample. So this one having coated with epoxy. This is not coated, and this one is not coated epoxy lah. So just want to test. Okay, so let's put there. So remember, on the right side here, it's coated with epoxy. This one, PLA alone, I mean straight from the 3D printer. Okay, this one also straight from the 3D printer, not coated. Only 4 here is coated. So we want to see, is there any different? In this case, we believe that the forming happen easily. I just want to see whether the epoxy can prevent the deformation of the object due to the heat of the plastic itself. So let's try. Okay, so wrinkle like that, you pull it up, and then we vacuum it. Okay, so no pop. Okay, no pop. But as you can see, this is the one that without epoxy. It's already deformed. It's look deformed. I'm not sure whether you can see from this angle or not. But here, it's look better lah. It's look better. It's look much better lah compare without what I call without coating. Okay, so you can see here, without coating, the PLA melt. But with coating, this just a single coat of epoxy. It just make a big difference lah compared to this. Okay, so the gap between the object is also important. As you can see here, there are what we call, there are some wrinkle in between this square and pentagon, because the what I call the gap is too small. You want the gap big like this, so there are no wrinkle lah. Normally there will be no wrinkle if there are enough gap. And also here you can see there are some what we call not thoroughly sucked by the air. So that's the reason why this what I call the hole here, the plastic not go until the end. Compared to this, you can see here is very flat, meaning that the vacuum suck until the end, so making the plastic goes until the bottom there. So it's better for you when you want to do vacuum forming, put your sample a little bit in the middle lah. Okay, and also make sure there are some gap to avoid some air pocket in between. Okay, so this is our final object to be vacuum formed today. It's quite complex object, have a lot of feature, the hole, the what I call the cylinder, the square, and so on. We coat this object with epoxy because we know that epoxy can prevent the PLA from being deformed during the vacuum forming. The problem with that, when you coat this with epoxy, some hole, for example, when you make a hole, it will be covered by the epoxy itself. So you need to sort of like drill again the hole. Okay. And also when you use epoxy, please don't put what we call the your sample on the on the something absorbing, for example like paper, because for example like this is a paper, A4 paper we put there, and then they close the hole. And also we try to take this what is this is a drill to drill the hole, but then our drill bit patah broken there. Yeah, so that's one of the problem lah, because we don't see the hole, so we need to sort of like guess where is the hole. But in doing so, our drill bit broken, we need to buy a new one. Okay, we're waiting our plastic to be heat up until 90 or 100 seconds. So this is example of what we call the successful vacuum form mold lah. So this is a car, and it's quite big. We use HIPS, high impact polystyrene. So you can see this is what we call the no undercut, and just to show that this machine are able to mold this big of stuff, and also with this height. Okay, provided you take into account all the design consideration. Okay, so now it's already 74. So another 10 seconds, maybe 10 or 20 seconds. So let's take it out. Okay, so finger crossed, we see. Take the lever. Okay, and okay, they are popped there. So yeah, let's see. So here we use the small reducing windows, and as you can see here, it doesn't really stretch to the edge. So we can say that it's better for us to use the big what we call the big plastic size lah. And as you can see here, there are very few what we call deformation of PLA, meaning that the epoxy does a good job lah here. Okay, so here they are our molded part. This is our original one, and you can see here they are hole, but there are no hole here. The reason being is because even though they are hole, and you can see inside there are small hole there, but because we use epoxy and I put this stuff on the paper, it stuck, the paper stuck, and I cannot see where is the hole. I try to drill, the drill broken. So effectively there are no hole here, so that's why there are nothing here. They are hole, but they are too small. So what will happen is that they cannot draw enough plastic in. Here is big, that's why you can see the indentation is much deeper lah. Here also deep also, and also the indentation there lah. But of course you cannot really assume to the end, because the hole here relative to the, this hole here is too small lah. So that's why it become like hemisphere. It's not like a cylinder, it's more like hemisphere there. Here, even though the hole until the end, until the bottom, is too much for this plastic to take the what I call the vacuum. So it's popped there. So you can see there are like hole there. And when it's popped, what happens is that there are less vacuum here. So that's why you don't see any feature there. As you can see here, there are some feature here, but there are no features shown here. Because why? Because the plastic already pop here, then the vacuum cannot really suck effectively around this part lah. And also you cannot see anything here, because why? Even though they are hole, but the hole is too small, that's why nothing here. And also another reason is because they pop here, the vacuum cannot go suck very well here. Okay, so now we try to drill the hole. Okay, hopefully our drill bit not broken again. So yeah, we have this what we call the sample that we did with the small plastic previously, but now we use the big plastic one, and we need to open the windows. So let's try. Hopefully this will fare better compared to previous one. So we open that. So So you can see this how it look like. Then we need to take this up. Macam mana? Oh, okay. Okay, and then we press vacuum. Where is vacuum? This vacuum, right?
Yes.
Okay. Okay, it still pop. Okay, so it doesn't matter whether you use a big or small. If they are pop, meaning that there are no vacuum, the vacuum will not be perfect lah. For the last part, we want to try this one, but using this HIPS plastic high impact polystyrene plastic. This is 1 mm thick. Because this plastic can stretch more than PVC accordingly. So we want to see whether this can assume the shape of this mold. And also we already grill this stuff previously. Our drill bit stuck there, so we just drill with the big drill bit in order to to remove the previous drill bit, because we don't want when the plastic drop inside it will touch the drill bit and pop. Okay. So this is the the condition now. It doesn't really matter whether it's not nice or whatever, because after all we will will form like this from the top. Okay, so long there are hole for the vacuum to draw the air, then it's okay. And also we make the hole in the middle there a little bit bigger. Okay, to see what will happen. This is our last look at our mold. So this make a bigger hole to remove our drill bit. This empty hole. This is still small hole, but they are like the hole over on the side. This we make it bigger. This as usual, and let's see. Okay. If you want to see what is inside here, you can look here. So you can see there are aqueous heating element. Okay, so there are 4 of that. You can see from this panel. So you go to the setting there. You can see there are 4 zoning, 1, 2, 3, 4, and 4 lah. So all of them is at 75% heating capacity, meaning that the maximum is 100%, and here we use only 70% max temperature lah. They don't have this in Celsius reading. So the one that we did previously is all at the same 75%. The difference is just the duration. So for 0.7 PVC, then we use around 120 seconds. For 0.5 mm thick PVC, we use around 90 seconds like that. And this for HIP, this is 1 mm thick, so we use around 200 second heating duration. Okay, we are at 150 there. So you can see, you can see here the HIPS plastic already going down there. It's become stretchy, so maybe it's quite time now. Okay, let's open. Okay, so this is how it look like, the HIPS. And then we bring our sample up and we test. Oh, there are no pop. There are no pop, and yeah, thickness matters. Yeah, thickness matters. Of course, there are. This is you have what we call the sheen there, because the distance is too short here. But amazingly, there are no pop, and you can see there the hole can go until the bottom, and here halfway, because of course it's only until halfway. This also at the bottom there. So yeah. So this also goes well to bottom. This also well to in the half, because our features only until the half. So what we can learn here is that this also you can see the feature can be seen lah. So the type of plastic that you use also matter lah. So this is HIP high impact polystyrene. is thick, maybe if we use a PVC that is 1 mm, then we can also get something like this lah. But we just have 0.7 mm PVC, that's why it's too thin lah for this. Okay, so this is the look at the back. So you can see now the color here become what you call transparent already. Because why? Because when you try to pull the plastic, they pull this thickness, the 1 mm plastic down there. So because it's thick, this thing is thick, then it change color there when it draw to the bottom, because when it go bottom it become thinner and thinner. Fortunately, this thing is thick enough to the point that it's not yet pop. I mean that they have still some plastic can go down and become thinner and thinner. So 1 mm is good lah for this height. This I think maybe 50 mm height. Yeah. So the thickness of plastic matters if your object have what we call height, some height lah. So as you can see here, if you have a hole, the distance between the hole, if this what we call the small gap is still okay. Even if you look here at the side wall to the hole, still okay. But if you have something protruded like this, then the gap matters lah. You can see there are the what we call the apa ni orang kata, what is this?
Wrinkle.
Wrinkle happen there. Okay, same like this. But if you have hole, even though the gap is little, it's okay lah. I think it's okay. This is not look nice because the what we call the plastic eat the 3D printed object lah. But if this is made from the ceramic, then I think it's nice. So the hole, the distance, I mean, it's not really what we call really matter much. But what's more important is the depth of the hole lah. But if you have something like protruding out like this, then the gap matters lah a little bit. Okay, and spirit. Okay, so those who want to get the service, you can come here. The detail I put in the description, yeah.